From time to time, I find myself in a situation asking very specific question. Why? It's one of the most ordinary, yet one of the most powerful questions. Why? It's a fountainhead of all knowledge. Everything can be explained through science. And what is the best source of knowledge? Our own projects. Here's the one I made.
My goal was to build a steering wheel game console with my own hardware and coding. I love racing, even though Alonso isn't winning much at the moment. Let me show you the components I used. First we have Arduino Pro Micro. This is the whole brain of this operation. This chip has a built-in USB hardware. That means that the microcontroller can be connected to the PC as a human interface device, or HID, the same system that the joystick has. And that's exactly what we need, a joystick device. Joystick works as a two potentiometers constantly changing their voltage and sending signals to the microcontroller. This signal is telling the PC how much did you rotate each axis of the joystick. For steering wheel, we would use one potentiometer or rotary encoder for one linear movement. This, however, wasn't my case, because potentiometers are sometimes very unstable and hard to be manipulated with when you're steering with them. So I had to use another way. I used magnetic encoder. Why can this tiny chip send the same current axis value as potentiometer? Let me explain. This chip contains Hall sensor. Hall effect is happening when electricity in a normal wire gets into magnetic field made by a magnet that is sideways to the direction of the current. Magnetic field is pushing the electrons to one side of the chip. But the electrons don't want to stay there, they want to go up again, they want to spread. But they can't, and they are releasing the pressure in form of voltage. So as the magnet spins, the voltage rises and falls. And this value of the voltage is being converted by the chip to an angle unit, which I easily added to the code. Now let me finally show the fun part, code. So I used Arduino IDE, and this is the whole code itself. I used these two libraries, and like I said before, we need Arduino to act like a joystick. So this line is translating the Arduino into joystick so that the PC can view it as a joystick. This is the list of the properties of the joystick, and the only need that we have is the x-axis, because we only have left and right rotation, and that's all happening in one axis. So that's the only thing that is true, and the rest is false, okay? We don't need it. Now, in this function we have the range of the x-axis, so it's over 4000 bits, which is quite precise. Here we have the value that I talked about before. This is the value from the Hall sensor, and it's changing while the magnet is rotating, thanks to these integers here. So it's either increasing or decreasing. And this line is making the electrons being pushed to the one side of the chip to actual value that the game can be working with. So that's what we need, and this is the whole code, and I just explained it very well now. Okay.
If I'd have to choose one thing from this project, it would be the making of something new. Now sure, I'm not the first person to build DIY steering wheel, but just like Henry Ford's automobile or the Germans V2, they all made something new, and that is why they changed the world.
Now let's take a look at the 3D model of the steering wheel. So here we have FreeCAD, and the first thing I started modeling was the steering wheel itself. So here it is. Yeah, this is the whole design, and yeah, it's the most basic design that steering wheel can have, but very effective. And there at the back is the hole for the shaft that will be going into the base of the console, and here is a little hole for the screw. The next part that we have is the shaft, so here it is, and now there are some features that I'd like to explain. This side is going to the steering wheel, and there's again the little hole for the screw, and this side is going to the base. And now, how do I connect the shaft to the base, you may ask? I'll just add two bearings so that a force is created to hold everything together, as you will see in a couple of moments. And there's also the little hole for the magnet, so that the magnetic encoder can work. And finally the base. So here it is, and I also made the little model of the magnetic encoder here. And there's a place for the two bearings, like I said, and also for the shaft that will be, of course, going through the middle. So that's the whole part, and now let's all assemble it together. Here we have the whole assembly, so as we can see, the shaft is sticking to the magnetic encoder so that the magnet can be right at the chip. And yeah, let's print it. With this guy making my parts done, I continued with the assembly. But first, let's make the electronics work. And with my equipment, I managed to put it all together. So this is it. That's my steering wheel, made with science and time that was meant to be spent differently.
I started this video with one question. The video is ending, but the question why remains unanswered. So why? Why build such a thing as a steering wheel? It was fun. I learned some cool physics. And it turns out, I can just do things. Isn't that bizarre?